Welcome to the Unit 3 mock exam. The date of the exam that I gave you was November 2015. The paper is in the new format that they've introduced through AQA, and that is that the signature sheet for the candidate goes all the way across the top of the page. In the old papers and the practice papers that you've been doing, there's been a marking scheme down the right hand side for examiners. That has gone. So when you get your paper to do your exam, don't be thrown by the format of the front page. The front page now looks like this for your AQA exam. All the other details on the front page are the same as they used to be, and we'll go through those in a minute. As usual, I've given you the shortcuts through YouTube to go straight to a question that you may have struggled with. So, using these shortcuts, just click on them and it'll take you to the appropriate question and save you time searching through the video. On the top of the front page, it's all about the candidate's details, and you'll be given these on the day on a card on your desk, and there'll also be the main details up on the whiteboard at the front of the exam room. You just need to confirm that you're taking the Unit 3 Foundation Tier exam, and the big F is the giveaway that you're taking Foundation. The date and time are on the paper, and the most important thing for you to manage through the exam is the time, and for Unit 3 you have 1 hour 30 minutes. There are 80 marks, so it's roughly a mark a minute that you need to be looking at. The details on the front of the page list the materials, and in this instance you will definitely need a calculator for the Unit 3 exam, and you'll need to know how to use that calculator, so get familiar with it before the exam. Also, in particular in this paper, you will need your mathematical instruments. That means a compass, protractor, pencil, ruler, rubber and so on, and they're particularly important in this exam as they are required on a couple of the questions. The rest of the instructions are the same, where you're required to use black ink and draw diagrams in pencil, because if you do it in pen and get them wrong, the paper becomes very messy very quickly. Answer all the questions, use the space provided, do all your rough working out in the exam book that you're given, and even if you have a pi button on your calculator, when you're using pi in the exam, I want you to use the number 3.14, because pi is an irrational number. It goes on forever, and rather than dealing with lots and lots of decimal places, if you leave 3.14 as your number for pi, then your calculations won't go on forever and ever. So please use 3.14 for pi. Under information, the marks for the questions are shown in brackets, so have a look at those and make sure you've got enough working out to get all the marks. The maximum mark is 80, so in 90 minutes that's a mark a minute, and it gives you 5-10 minutes at the end to check your questions. In some questions you're required to write things down, and in this paper they are questions 11, 12, 17 and 20, and they'll have a little asterisk by the particular parts of the question to let you know you're expected to write some words down, not just numbers. You can ask for more paper for working out or graph paper, but in particular in Unit 3 I would always ask for tracing paper, and again in this paper you probably will require tracing paper to answer at least one of the questions. In the advice, the most important piece of advice for the whole exam is show clearly how you work out your answer. There are more marks for the working out than just writing the correct answer on the answer line. If all you do is write the correct answer on the answer line, you will fail this exam badly, and we don't want you to fail it, we want you to pass. So show your working out. On the inside of the front cover is the formula sheet, This isn't anything for you to work out. It appears on every single Unit 3 paper, and it's just in case you need to work out the area of a trapezium or the volume of a prism, and it actually gives you the equations for both of these. So should we come across these in the exam, we will refer to these formula sheets that are inside the front cover. They are not questions. Let's start the exam then. Question 1A. It says shade 25% of the centimetre grid. So if you look at half of the grid, you would cover 6 squares. So if you're looking at half of a half, you need to shade in 3 of the squares, and that's 25% of the centimetre grid. As always in Unit 3, there are lots and lots of ways of doing these questions. If you've come up with your own way of answering these questions and getting the right answer, then that's fine. You don't always have to have the method that I use. Question 1B. Work out the fraction of this centimetre grid that is shaded. Give your answer in its simplest form. Well, on this grid we have 1, 2, 3, 4, 5, 6 by 2, so we have a total of 12 squares, of which 1, 2, 3, 4, 5, 6, 7, 8 of them are shaded. So we need to simplify this to get our fraction in its simplest form. Well, 8 and 12 are both divisible by 2, and it becomes 4 divided by 6. Again, we can divide this by 2 to get 2 over 3. So the answer on the answer line for our fraction in its simplest form is 2/3. Question 2 is about using the appropriate units, and it lists a load of units for you. It's asking you to choose the best unit to complete each sentence. The first question says the length of a classroom is measured in, and I would measure this in metres. The second question says the mass of an average human is measured in, and I would say it's kilograms. And then finally, the amount of water in a full bath is measured in litres, because it's quite a large amount. Question 3 states that the diagram shows 5 lines on a square grid, and each of the lines has a letter at either end. So we have line A, B, C, D, and so on. Question 3A asks which 2 lines are parallel. So you need to know the definition of parallel, and that is the lines run together and will never meet. So the 2 parallel lines I can see look like C, D, and E to F. So the parallel lines are C, D, and E, F, and that's what you'd circle. The question then asks which 2 lines are perpendicular. So to be perpendicular, one line has to hit another line at 90 degrees. So to find a line that does that, AB looks like the obvious line that's coming in this direction that will hit the other lines at 90 degrees. Because it's going one across and one down, in other words, exactly diagonal across these squares, we need to find another line that does the same in this kind of direction. And the only line that we have that does that is line GH. So it must be AB paired with GH. The final part says which 2 lines are the same length. Now in theory they all create triangles, and if you create right angle triangles you don't want to be doing Pythagoras 5 times. all you need to do is look at the two smaller sides. So that's a 2 by 2 triangle. Now what you're looking for on your right angle triangles are sides that are the same length. This is 3 by 3. This line here, J to K, is made up of 4 by 2. E to F is 1 by 2. So they've all been different so far. So really the one that should match up is C to D. And this is 2 by 4, which matches up with J to K. So C to D matches up with J to K. And we know the hypotenuse on both of those triangles must be the same. Therefore the lengths are the same. Question 4a. Work out the shaded area on this centimetre grid. State the units of your answer. And there are 2 marks. So it's 1 mark for the correct area and 1 mark for the correct units. Now, when you get these centimetre grids, the way to work out the area is just count the shaded squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11, and because it's a centimetre grid, it's going to be centimetres, and they're going to be squared. Question 4b is asking us to draw a rectangle on this centimetre grid with a perimeter of 18 centimetres. So when you have a rectangle and it has a perimeter of 18 centimetres, the length and the height have got to be half of the total perimeter. So 18 divided by 2 means that when we add our length to our height, they've got to equal 9. So you can have any combination you like to do this. So you could have a length of 5 and a height of 4 to create your perimeter of 18 centimetres. So let's do that. Create a length of 1, 2, 3, 4, 5 and a height of 1, 2, 3, 4. A length of 5 and a height of 4. And there we have our 5 by 4 rectangle that has a perimeter of 18 centimetres. 5 and 5, which is 10, 4 and 4, which is 18. Question 4c is asking us to draw a rectangle on the centimetre grid with a perimeter of 16 centimetres and an area of 12. So using the same technique we used in question 4b, let's look at the perimeter first. So our length and our height need to add up to 8, because this is half of our complete rectangle. So we need a combination of numbers that when added together give us 8, but when multiplied together give us 12. Well, all you need to do is go through your factors of 12. 1 and 12, well no, when I add them together I get 13. 2 and 6, well when I add them together I get 8, and when I multiply them I get 12. So that's my answer. When I add 2 and 6, I get my perimeter for half of my rectangle of 8, and when I multiply them together, 2 times 6 gives me the area I'm looking for by 12. So I need to draw a rectangle of 2 centimetres by 6 centimetres. So our base, or our length, is 6 centimetres. 1, 2, 3, 4, 5, 6. And our height is 2 centimetres. 1, 2. Again, the top of our rectangle is 6. And our width, or our height again is 2. So that's the rectangle, which has a perimeter of 16 and an area of 12. A length of 6, 2, 6, 2 gives us a perimeter 6 plus 6, which is 12, 14, 16, and then an area of 6 times 2, which is 12 centimetres squared. Question 5 says that the diagram below shows half of an arrow. 4 arrows are joined to make this shape. So here we have quite a strange looking shape by joining 4 of these things together to create it. It says draw all the lines of symmetry for this new shape. Well, a line of symmetry, if I put a line down there, one side reflects onto the other side, which is the line of symmetry. If we do the same across the centre, that again creates a line of symmetry. So there are 2 lines of symmetry for our shape. A good indicator that there's more than one would be the marks. If there was 1 line of symmetry, it would probably only have 1 mark for the question. So here we're using exam technique to think about the number of answers. Question 5b says one of the 4 half arrows is shaded on this diagram. So here we have a shaded area for one of our half arrows. We need to shade another half arrow so that the diagram has only 1 line of symmetry. So to create 1 line of symmetry, if we use our 1 line of symmetry as our vertical line of symmetry that we drew on 5a, then we would have to colour in this part of the half arrow to create that 1 line of symmetry so it matches the grey area on the left hand side. So that's one of the possible answers. Another possible answer could be the other line of symmetry that we drew, which is this line here. So in order to reflect this grey area on our shape, we would have to draw another half arrow and shade that in to have 1 line of symmetry, but this time the line would be a horizontal line of symmetry. So that's an alternative answer to this question. Question 5c again uses the half arrows, but this time there are 2 of them shaded in this particularly complicated diagram. However, it's asking us to shade 2 more half arrows so that the diagram has rotational symmetry of an order of 4. And what that means is if we put a pin in the centre of our shape here and span it around, it would lock onto itself 4 times. So we have an order of rotational symmetry of 1 at the moment, because this shaded area here then maps onto this shaded area here. And we need to do the same another 2 times to give it an order of 4. So we would have to create and shade a half arrow here, so that when this one goes around, it maps onto here. And then finally, we would move this arrow around 90 degrees and create a shaded half arrow here. So when we go round 90 degrees, this area here maps onto this shaded area here. And our shape would now have rotational symmetry of order 4. Question 6. Here is a diagram of a man standing by a building. It then tells us that the actual height of the man is 1.7 metres. Now sometimes they don't tell you this, so it's a good thing to remember and take into an exam. It's asking us to work out an estimate for the height of the building. So if our man comes up to here on the building, we just need to repeat the number of times that space occurs, which is approximately 1, 2, 3, 4 men high. So all we need to do to get our answer is multiply 4 by our 1.7 to give us our answer. And this is an example where, even though it's a straightforward calculation, you would use your calculator. So 4 times 1.7 equals 6.8 meters. And don't forget to write the answer on the answer line. Question 7 is a diagram that shows the net of a cube, and it's actually the net of a dice, as if we'd rolled a dice out flat, unfolded it. And it's asking us to put the numbers on the blank faces so that the opposite faces of the cube add up to 7, just like a dice. When you look at a dice, one side is 6, then the opposite side must be 1. So if we were to fold this up, then this side would be the side that's opposite. So 6 is opposite to 1. 5, when we fold this up, would be opposite this side here. So this must be 2. And that leaves 3, which is when it's folded, would map up with this, be opposite this side here, which would be 4. So the solution is 5, 4, 2, 3 across the centre, and 1 and 6 opposite each other, top and bottom. Question 8 tells us that 5 miles equals 8 kilometres, which is unusual because they usually expect you to take that knowledge into the exam. It's asking us which is longer, 26 miles or 45 kilometres, and we must show our working out. So we can convert either, but the most important thing is it's a ratio of miles to kilometres. There are 5 miles to 8 kilometres. So let's convert the miles then. We know the miles is 26 miles. So you have to ask yourself, what did I multiply 5 by to get 26? Well, that's a simple calculation. 26 divided by 5 will tell you the factor that 5 has been multiplied by. And the answer is 5.2. So all we need to do is go on the other side and multiply 8 by 5.2, and it will tell us the number of kilometres 26 miles is. Now again, use your calculator for all of these calculations. So 8 times 5.2 gives us 41.6 kilometres, 41.6 on our ratio. So 26 miles is 41.6 kilometres, which is less than 45 kilometres. So 45 kilometres is longer. Question 9 is about adult tickets. Not quite sure what the tickets are for, but an adult ticket costs £65.50, a child ticket costs £35.25. Kate has £105. She buys one adult ticket and one child ticket. How much does she have left? So a nice straightforward question. Again, I would use my calculator, where we need to add the price of an adult ticket, which is £65.50. So show the examiner what you're putting into your calculator, and add £35.25 for the child ticket. And I get £100 and 75 pence. So in order to work out how much money she has left, you have £105 that she gave, you take away £100 and 75 pence, and again, using your calculator, do the calculation. And you get the answer, £4.25. So on the answer line, £4.25. Question 9b tells us that Gina buys 5 tickets and she pays exactly £267. How many of each type of ticket does she buy? Now you can do this by trial and improvement and try all the combinations of tickets. 1 adult and 4 children tickets, 2 adult and 3 children tickets, and so on. But there is a quicker way of doing it. If you notice, there's no spare pence when she pays. So there has to be an even number of children tickets. She has to have either bought 2 or 4 children tickets. Now, if you go for the 2 children tickets, then it leaves 3 adult tickets, and then 2 lots of 25 pence would be 50 pence, and 3 lots of adult tickets would be £1.50 if we were just looking at the pence. And that's a nice 200. So just looking at the numbers, you can take a guess that she bought 2 child tickets at £35.25, which gives us £70.50. This would leave 3 adult tickets at £65.50, which, when we put it in our calculators, gives us £196.50. And when we add the two together, again on your calculator, is that exactly £267, which is what we're looking for. So she bought 3 adult tickets and 2 child tickets. Question 10 is a construction question where they've given you a triangle and the measurements are in meters. It's asking us to use a scale of 1 centimetre, which represents 20 meters, and we need to draw a scale drawing where the base has been drawn for us. Before I reveal how we're going to do the drawing, let's look at each of the measures on our triangle and convert them using our scale factor. So for one of the sides I have 160 meters, and 1 centimetre represents 20 meters. So I need to divide it by 20, and I can do this on my calculator. It tells me I need a line to be exactly 8 centimetres long. The other side we're going to need to draw is 200 meters, and when I divide it by my scale factor of 20 meters per centimetre, I end up with a line that I need to draw that is 10 centimetres long. The third line, the 240 meters, has been drawn for us, but just to show you, that line should be 240 divided by 20. It should be exactly 12 centimetres long, and we can check that in a second. Let's look at drawing our triangle now we know the lengths of the sides we need to draw. Now they've given us the base already. It tells us the base is drawn already. So I've represented that as the green line on this diagram. Now what I need to do is draw a side, side, side triangle, because we've been given the length of 3 of the sides. Now one of the sides, the baseline, has been drawn, so all we need to do is place our compass on our ruler and measure out 8 centimetres to get our 160 metre line. You place your compass at the end of the baseline and draw your swoosh ready for the crosscut. You then need to change the length of your compass to your second side, which is 200 meters or 10 centimeters on our scale. So stretch your compass out to 10 centimeters, move the point to the other side, flip your compass around, and then draw the swoosh that cuts through your 8 centimetre line. And that's us done with the compass. Now what we need to do is draw a line from each of the ends of our baseline and label our diagram. So draw a line from the left hand end to the crosscut, which is our 8 centimetres, and from the right hand end to the crosscut, which is our 10 centimetres. And label the diagram 160 metres, 200 metres, and the base, which is 240 metres. And the examiner will be looking for the compass marks, the construction lines, for you to get all of the marks. If you do it by trial and error with a ruler, then you're not going to get all the marks, even if your diagram is accurate. Question 11a. The diagram shows a square, and we need to work out the perimeter of the square when x equals 4.5. So this is an algebra substitution question where we're required to substitute 4.5 for the letter x. So 4x means 4 times whatever the value of x is. So 4 times 4.5. Don't take any chances, use your calculator. And the answer is 18. Then we need to add the 3, the second part of our expression, and that gives us 21. So one of the sides is 21 centimetres, but it's asking us for the perimeter, so don't lose sight of what the question is asking us. So because it's a square, all of the sides, all 4 sides, are 21 centimetres. So again, put this in your calculator to get the correct answer, which is 84 centimetres. So the perimeter of our square is 84 centimetres. Question 11b gives us the diagram of a triangle, and here we have some values for the angles of 2y plus 30 degrees and 3y plus 15 degrees. And it's asking us to show that the triangle is equilateral when y is equal to 15. So in both of our expressions for our angles, we have to swap the value of y for the number 15 and then prove that it's an equilateral triangle. So 2 times, now substituting y for 15, gives us 30 degrees. Plus the 30 degrees on the second half of our expression gives us 60 degrees for the angle at the top. For the second expression, 3 times 15 gives us 45 degrees. Plus the 15 degrees on the second half of the expression gives us 60 degrees. So if 2 of the angles are 60 degrees, and so here you could actually write it, because it's expecting a written answer, if 2 of the angles are 60 degrees and a triangle has a total of 180 degrees, then the final angle must be 180. Take away our 60, take away our other 60, which equals 60 degrees. Therefore, it is an equilateral triangle. Something along those lines. Question 12 is asking us to look at this map and measure and write down the 3 figure bearing, so it's giving you a big hint here, of B from A. So when we do bearings, when you're measuring the bearing from something, the from becomes the reference point. So to help us measure that angle from A, we draw a line from A to B. We then place our protractor and the crosshairs on the centre of A and read off the angle that it goes to B. So looking at our protractor, we have to go around from north to the bearing we're interested in. So our reference north from A, around to B. If this is 0, so we can rotate our protractor. There we go, it's rotated with north. So now we have 0 and we measure our angle around. And as you can see, 0, 10, 20, 30, we have a bearing of 40 degrees, but with bearings you have to remember the leading 0. So on the answer line, they're expecting to see the bearing 0, 4, 0 of B from A. So this bearing here is 0, 4, 0. Question 13. An isosceles triangle and a quadrilateral are joined to make up this shape. The base of the shape is a straight line. Work out the angle of Y. Okay, so we have a quadrilateral and we know that the angles inside a four-sided shape, no matter what it looks like, add up to 360 degrees. So what we need to do to find this missing angle here is have 360 and take away the 3 angles that we do know, which is 80, 75 and 78, and see what we get. So using your calculator again to do all of these calculations, put your answer down. And the answer you should get is 127 degrees. So the missing angle inside our quadrilateral is 127 degrees. Now, it told us that the baseline was a straight line, therefore we can calculate this angle on the inside of our triangle, and that is 180 take away the 127 degrees we already know. Again, use your calculator for this, and you should get 53 degrees. So this angle here is 53 degrees. Now, on an isosceles triangle, because of these marks that we have on our triangle, the angle in the bottom left here must be the same as the angle in the bottom right here. So the 2 equal sides have the 2 equal angles at the bottom. So we have a total so far of 53 degrees plus 53 degrees inside our equilateral triangle, and that is 106 degrees. So Y must be equal to 180 degrees, because that's the angles, the total of the angles inside a triangle. Take away the 106 degrees for the 2 angles we already know. So the missing angle must be 74 degrees. So the answer is 74 degrees. Question 14. The diagram shows a rectangle with dots on 2 sides. The coordinates of A, C and E are shown in the diagram, where the distance from A to C is the same as the distance from D to F. The dots on each side are equally spaced, and it wants us to work out the coordinates of B, D and F. So what you have here is a coordinates question where normally you would expect to see your grid lines for your coordinates, and they've just removed them to leave you with this shape and these dots. So what we need to do is think as if there was a grid on top of this image, and we've been given some clues that A is -5, 2 and C is 3, 6. So you need to ask yourself, how do I get from my x coordinate to my x coordinate? Well, I go from -5 to 3, I go 8 across. And then you have to ask yourself, to get from A to C, how many do I go up? Well, I go from 2 to 6, so I go 4 up. And that's all we really need to know to solve this question, because point B is halfway between A and C. So from A, instead of going 8 across, we go 4 across. So -5 plus 4 gives us -1. And instead of going 4 up, we're just going to go 2 up. So instead of 2, we add 2 plus 2, which gives us 4. So to our 2, we're going 2 up, and we add 2. So -1, 4. So B has the coordinate -1, 4. And that looks right as well. Now, because the spacing for D, E and F are the same for A, B and C, from D across to F is 8, and from D up to F is 4, and we can use that again to work backwards from E to find D. So we're going back from -2, and we're going 4 places back from -2, half our distance. So -2 minus 4 is -6. And from E, from 10, we're going down 2 places from 10, half our distance of our rise. So 10 minus 2 is 8. So the coordinates of D is -6 and 8. Now let's look at F with respect to E. From E, we need to go right 4 places. So -2 plus 4 is +2. And from +10 going up 2 is 12. So our coordinates for F are +2 and 12. Question 15. This is asking us to work out the area of this irregular pentagon. So we've got a 5-sided shape and it looks quite familiar. Now when you see these complicated shapes, you can divide them into 2 simple shapes. So quite straightforward, by putting the purple line straight down, you can see a rectangle which is 10 centimetres by 12 centimetres. So that's quite easy to work the area of. So we have 120 centimetres squared for our rectangle. Now we need to work out the area of the triangle, and they've made it relatively easy for us because the base of our triangle from here to here is 10 centimetres, and the height of our triangle from the base to the tip is 18 centimetres, which is the full width of our pentagon. Take away the 12 centimetres, that is our rectangle, and it leaves us a height of 6 centimetres for the triangle. Now you need to know the area of a triangle is half of the base times the height. So we just substitute our values in. 1/2 times 10 times 6. So that's the half the base times the height. When we do that calculation, and you can do this on your calculators, you end up with 30 centimetres squared as the area of our triangle. All we need to do now to work out the area of our pentagon is to add the area of our rectangle, which is 120 centimetres squared, and the area of our triangle, which is 30 centimetres squared. And you should get 150 centimetres squared as your answer. Don't forget to put the answer on the answer line. So 150 centimetres squared. Question 16a is asking us to enlarge a shape by a scale factor of 2, and the centre of the enlargement has to be the point P. So this is one of those questions where they've given us a centre of enlargement. The way I showed you to do this in the class is take a reference point, which is usually the point closest to our centre of enlargement, and count the number of squares across, which is 2, and the number of squares down, which is 1. And because we're dealing with a scale factor of 2, we double each of those distances. So we go 4 along and 2 down. So the corner of the triangle that is our reference now lives at this new point here. Then all we need to do is construct the triangle from our reference point. So our original goes 2 squares down, so we go 4 squares down because it's a scale factor of 2. So from our reference, 1, 2, 3, 4. So this corner enlarges to this corner over here. And then finally, the top of the triangle, 1, 2, 3 along, becomes from our reference point, 1, 2, 3, 4, 5, 6 along. So it now lives there on our enlargement. And we have enough points to reconstruct our enlarged triangle, our image. And it looks like that. So this new triangle shows an enlargement of our original triangle using the enlargement point P. Question 16b is asking us to describe fully the single transformation that maps A onto B. Now when you think of your transformations, you need to think about reflection. Well, can I reflect A onto B down a line which would have to be something like that? Well, no, because the top of it would look something like that. So reflection doesn't work. Then if I was to translate it, in other words, slide it along, if I slide A along this way and then slide it down, again, my transformation would be the wrong way around. So it's not translation. So we're looking at rotation. Now some of you may be able to see clearly that from this reference point to this reference point, it's rotated around 180 degrees, about 0, 0. So our answer could be gathered just by looking at it and working out its rotation. If you struggle seeing the rotation, then you can use the tracing paper method. So trace over your triangle A, placing your pencil on the origin, select your triangle, and I'm not able to do it on this software on the computer. Hold your pencil on the origin and the image, when you spin it around the center, will end up on top of B. So your object will end up on top of your image. And that can be done by tracing paper. If you can visually see that the origin is the center and you can rotate it, then you can give the full description, okay? And because it says describe fully and there are 3 marks, you need to think about the information you're writing down. So it's a rotation about 0, 0, and it's 180 degrees. And it doesn't matter, because it's 180 degrees, whether it's clockwise or anti-clockwise. So rotation is 1 mark, about 0, 0, so the center of your rotation is a 2nd mark, and then how far you've rotated, which is 180 degrees. And that's your 3 marks. Question 17 is about a gardener who uses a formula to work out how much he charges to make a lawn. Now, it looks like a complicated formula, but when we read the rest of the question, that C is pounds and A is the area, he's going to make a rectangle using the lawn of 12 metres by 17.6 metres, and we need to know how much he's going to charge. So the first thing we need to do is calculate the area and substitute it into our formula. So the area of a rectangular lawn would be 12.5 metres multiplied by the 17.6 metres. And this is definitely one of those you're going to put in your calculator. And that's exactly 220 metres squared. So that's the number that A is going to become. Now the formula isn't that difficult if you know the algebra and what things are saying. So the 7 next to a bracket means 7 multiplied by 14 plus, and we can now put in our 220. And then the all over 3 means divide whatever you do at the top by 3. So if we break that into stages, it becomes 7 times 234 all divided by 3. And then when we do the top bit first, so we multiply 7 by 234, we end up with 468 all divided by 3. And then when we put this in our calculators, we get 156 pounds exactly. So the answer on the answer line is 156 pounds. Question 18 has a diagram showing a water tank in the shape of a cuboid, which is 40 by 40 by 90. The tank is full of water, and they're telling us that 1 litre is 1,000 centimetres cubed. It's not something you need to remember in the exam, and they will give it to you. However, some of you, when you read the next part of the question, will cotton on to a conversion you do need to remember. And that is, how many gallons of water are in the tank? So it's one of the conversions you need to remember to take into the exam. 4.5 litres is 1 gallon, and you need to remember that conversion ratio to get all of the marks in this question. But there are some marks we can get before we get to that point. The first thing we need to do is to work out the volume of the full water tank in centimetres cube. So let's do that. So working out the volume, look at the basic shape facing you. So it's a 40 by 90 rectangle. So 40 times 90 tells us that the area of the rectangle facing us, doing this on our calculator, is 3,600 centimetres squared. And now we multiply it by our depth, our third dimension, so 3,600 times by 40 again gives us, putting this in our calculator, a volume of 144,000 centimetres cubed. So now we need to convert this centimetres cubed into litres using the conversion we've been given. So 1 litre is centimetres cubed, 1,000 centimetres cubed. And I've got 144,000. So to work out the scale of what did I multiply 1,000 by to get 144,000, you divide the 144,000 by the 1,000, which is quite a nice, easy thing to do, because the zeros cancel each other off, and I've actually multiplied it by 144. So, to work out my litres, I multiply it by 144, and I have 144 litres of water in this tank. So when we go to our gallon conversion, I know I have 144 litres. So to work out the conversion factor of how I go from 4.5 to 144, it's exactly the same technique again. I get 144 and I divide it by 4.5. So you'll probably need your calculator this time. And it's exactly 32. So I need to multiply the other side of my ratio by 32 to work out that 144 litres is 32 gallons. So the 32 gallons goes on our answer line. Question 19. The diagram shows 3 straight lines, but they're not just 3 straight lines. Because of these annotations, 2 of the lines are parallel, and the third line that we have here is what we call a transversal. It's cutting across 2 parallel lines, and it throws up some rules. So question 19a is asking us which of the following describes the angles marked. So with our transversal, one is on one side of the transversal and the other is on the other side of the transversal, and they're what we call alternate angles. They're on the alternate sides of the transversal. Sometimes people call it the Z angle, but in maths you haven't been given the option of the Z angle, and they ask you to call it by its proper name, which is the alternate angle. Question 19b is asking us to work out the value of x. Well, alternate angles are the same, so in theory we're creating an equation that says 2x plus 100, our first angle here, is exactly the same angle as 3 into 4x minus 20. Close the brackets. So we've kind of got an equation that we need to solve. Now to solve the equation, the first thing you're going to need to do is open the brackets. So we still have 2x plus 100 on this side of the equation, but when I open my brackets, the 3 times the 4x becomes 12x, and the 3 times the 20 becomes minus 60. Now whenever you have a 3-step equation where our variable is on both sides, I always advise you to move the smallest variable to the bigger variable. So in this case, take away 2x from this side and you have to do the same on that side. So now on the left hand side you're left with 100, and 12x minus 2x gives us 10x minus 60. Now, to get x on its own, we're now looking at something very familiar, which is a 2-step equation. Step 1, we add 60 on both sides, so we end up with 160 on the left-hand side of our equation and 10x on its own on the right. But we don't want 10x, we want x on its own. So to get x on its own, the second step is divide by 10, divide by 10. And when you do that, x is equal to 16. And we can check it if we want to. 2 lots of 16 is 32, plus 100 gives us an angle of 132 degrees here. To check it on this side, 4 lots of 16 is 64, minus 20 is 44, and 44 times 3 gives us 132. So we know that 16 degrees is the correct answer. Question 20 is a question on washing powder, which is sold in 2 sizes. We have 600 grams and we have 1500 grams. Which size is the better value for money, where the smaller one, 600 grams, is £3.30, and the bigger one is 1500 grams and it was £9.60, but there is 15% off. And we need to show our working out, and there are a massive 6 points for this question. So there's a lot of working out that we can do to get most of these 6 marks before we ever get near the answer. So let's do the first one and work out what the proper price of our large box of washing powder is. So we have £9.60 and we need to take off 15%. So 15 over 100 represents our 15%. So what do we need to take off our £9.60? So let's put that in our calculator. 9.6 times 15 divided by 100. And that tells me we need to take off £1.44 from our price. So £9.60 minus £1.44. Again, do it on your calculator, don't take any chances. Gives us £8.16. So the price of the large washing powder is £8.16 for 1500 grams. Now all we need to do is compare like with like. You can do it by going to find out how much 1 gram is, because we've got a calculator, that's quite easy to do. Or we can do it by matching up the number of grams and finding a number that's common to both 600 and 1500. So let's try it that way first of all. Let's look at our small box, and we have in grams 600 grams, and it costs £3.30. Now the first number that 6 and 15 have in common is 30. So if we have 3000 grams for each box, then we're comparing like with like. So this makes it nice and easy. If I make it from 600 to 3000, I've multiplied the weight by 5. And all I need to do is multiply the money by the same amount. So £3.30 times 5 tells me it would cost me £16.50 to make 3000 grams using just small boxes. Now let's look at the large box and do the same thing. The large box, grams to pounds, is 1500 grams and it costs £8.16. And to get 3000 grams, so we can compare like with like, I've multiplied it again by a nice easy number, which is 2, which is what I have to do to the money. So 2 lots of £8.16, don't take any chances, put it in your calculator, is £16.32. So on your answer line, it's asking for some text. You would write down the answer. The 1500 gram box is the better value. And that's what I would say. Question 21. The diagram shows a square and a circle. The area of the square is 49 centimetres squared and the perimeter of the square is equal to the circumference of the circle. Work out the radius of the circle and give your answer to 1 decimal place. And again, the question has got quite a lot of marks on offer. So let's break it down into the stages. If we have a square of 49 centimetres squared, just like we did with Pythagoras, how do you work out the length of the side? Well, the reason they've given you 49 is because it's easy to identify it as a square number. It's the result of 7 times 7. So the length of each of our sides on a square has to be 7 centimetres to create the area of 49 centimetres squared. So the first part is the length of the square is the square root of 49, which is 7. Now, to work out the perimeter of the square, it's 7 times 4 because each side is 7 centimetres. So that's 28 centimetres is our perimeter. Now that perimeter is the same length as the circumference. Now as soon as you see circumference and circles, you need to write down the equation. So the circumference of the circle is equal to pi times the diameter. And they're asking us for the radius. So let's just work out the diameter first. We know the circumference has to be 28 because it's the same as the perimeter of the square. So 28 is equal to 3.14 times the diameter. Now, we want the diameter on its own, so we divide both sides by 3.14. The other way to remember this is our triangle to help us to deal with circumferences of circles, because the circumference of the circle is pi times the diameter. And we've got the value for the circumference and we've got the value for pi. So to get the value of d, we divide c by pi, which is exactly what we're doing here, dividing the circumference by pi. So on your calculator, 28 divided by 3.14, do not use the pi button, we get 8.917, which is equal to our diameter. Now I'm going to leave the accuracy of this number because it does go on 917, 452 and so on. I'm going to leave this accurate to 3 decimal places for the moment because we haven't quite finished. To go from the diameter to the radius, we need to divide the diameter by 2 because the diameter goes from side to side and the question is asking for the radius. Okay, so we need to divide our answer by 2 for our diameter. So our radius, when we divide this 8.917 divided by 2, might affect our result. So it's 4.458, and that's what we get for our radius. Now they want it to 1 decimal place, so we need to do a bit of rounding. They're interested in the 1, but we need to look at the next number along, which is a 5. So when you get to a 5, you round up. So to 1 decimal place, you would expect the radius to be 4.5 centimetres. And that's the end of the questions. This was an Archie the Pooch production. I hope it was of use to you and that you got something out of it. Good luck for your exams in June, and if you need anything, you know where to find me.